Hi everyone, welcome to our physics class. In the previous class, we have studied about reflection of light. Okay, so what is the meaning of light? Light is a form of radiant energy which causes the sensation of sight in the eye and also in brain. So a straight line along which light can travel, that is called a ray of light, bunch of rays, bundle of rays, collection of identical rays. So that is called the beam of light. So what is the meaning of reflection of light? So when a ray of light is incident on a reflecting surface, the ray turns back, bounces back into the same medium. So that is called the reflection of light. So there are two very important laws of reflection. Number one, the incident ray, reflected ray, and the normal at point of incidence all lie in the same plane. The second one is the angle of incidence, that is exactly equal to the angle of reflection. So those are the two very important laws of reflection of light. Suppose when a ray of light is incident normally, what happens? The ray retraces the same path. So in that case, the angle of incidence is equal to 0. Angle of reflection is also equal to 0. Right? So after that, we have studied about the special kind of mirrors, that is spherical mirror. A spherical mirror is a smooth spherical reflecting surface. Spherical reflecting surface is spherical mirror. So that is of two very important types. One is concave and another one is convex. Okay, so what is the meaning of concave mirror means silvered on inside, opaque portion on outside. So if the light gets reflected from inside the surface of a part of a hollow sphere. Okay. So what is the meaning of convex mirror? The light gets reflected from outside the surface of a part of hollow sphere, that is convex mirror. So this is concave mirror, this one is the convex mirror. So concave mirror, that is also called converging mirror because it converges the parallel beam of light. Okay, so when the parallel beam is incident on the silver surface of the concave mirror, so after reflection, so all the reflected rays that is meet at a point on the principal axis. So this is called the principal focus. Okay, so what is this? The center of curvature. And this one is the pole. What is the meaning of pole? Pole means the center of the reflecting spherical surface is called pole. Okay, so this is the converging mirror because it converges the parallel beam of light. Okay, so what is this? Principal axis. So what is the meaning of principal axis? Line passing through the pole and center of curvature. Line passing through pole and center of curvature. So this is called the principal axis. So this is center of curvature, that means center of the sphere, but the given mirror, that is a part. Okay. So here this is the pole of convex mirror. And this is center of curvature of convex mirror. and this is the principal focus. So when parallel beam of light that is incident on the silver surface of convex mirror, so after reflection, the reflected rays appear to diverge. The reflected rays appear to diverge from the virtual focus. So after reflection, the reflected rays appear to diverge from the principal focus. So this is also called the diverging mirror. So this is also called the converging mirror. Okay. So and then we have discussed some very important terms connected with the spherical mirror. That is pole. Pole is the center of reflecting spherical surface, the center of curvature, center of the sphere, but the given mirror is a part. And the radius of curvature, what is the meaning of radius of curvature? That means the radius of the sphere, but the given mirror, that is a part. Okay, so radius of curvature, that is radius of the sphere, but the given mirror, that is a part. Okay, so a line passing through pole and center of curvature, that is called the principal axis, and this is the principal focus. Principal focus is the point on the principal axis where the parallel beam of light converges or appear to diverges after reflection, right? So what is the meaning of concave mirror? If the light gets reflected from inside the surface of a part of hollow sphere is concave. If the light gets reflected from outside the surface of a part of hollow sphere, so that is called convex. Okay, the next very important topic, that is new Cartesian sign conventions, that is used in spherical mirrors. The first new Cartesian sign convention is that all ray diagrams drawn with the incident light, all ray diagrams drawn with what? The incident light. Okay, so that must traveling from left to right. So all ray diagrams drawn with the incident light, that must traveling from left to right. So this is the first, the new Cartesian sign convention. And the second one, all the distances are measured. All distances are measured along the principal axis from the pole. Okay, so all distances are measured along the principal axis from the pole. So that is the second new Cartesian sign convention. The first one is all the ray diagrams are drawn with the incident light must traveling from left to right. So all the distances are measured along the principal axis from the pole. Okay, if the distances are measured, in the direction of incident light, such distances are taken as positive. If the distances are measured opposite to the direction of incident light, such distances are taken as negative. Okay, now look at this two ray diagrams. Actually here, how do you measure the focal length? So all the distances are measured, that is along the principal axis from pole. So focal length is measured from pole to focus. Focal length is measured from pole to focus, because all the distances are measured along the principal axis from the pole. So focal length is a distance that is measured from where to where? Pole to focus. So this is actually pole to focus, that is from left to right. So the direction of incident light is also left to right. So if the distances are measured in the direction of incident light, such distances are taken as positive. So here in convex mirror, the focal length is positive. Focal length is positive. So what about the radius of curvature? Radius of curvature is measured from where to where? Pole to center of curvature. Is it not? So this is the radius of curvature. Pole to center of curvature. So this is the radius of curvature. Okay, so pole to center of curvature. So this is from left to right. So direction of incident light, that is also left to right. So it is in the direction of incident light. So that is why, so radius of curvature is also positive. So in this case, the focal length is positive, even the radius of curvature, that is also positive, because both distances are measured along the direction of incident light, in the direction of incident light, that is from left to right. Okay, left to right distances are positive, right? But look at this diagram. Actually all the distances are measured along the principal axis from the pole. So here pole to focus. So this is the focal length. Pole to center of curvature. So this is radius of curvature. So pole to focus is opposite to the direction of incident light. Okay, pole to focus distance, that is from right to left, direction of incident ray, that is from left to right. So this distance is opposite to the direction of incident ray. So that is why here the focal length of concave mirror is negative. And pole to center of curvature. Okay, so this is also opposite to the direction of incident light. So the radius of curvature is also negative. Focal length and radius of curvature is positive for convex mirror. Focal length and radius of curvature is negative for concave mirror. According to the new Cartesian sign convention. The focal length and the radius of curvature of concave mirror is negative. And focal length and the radius of curvature of convex mirror, that is positive. right? So the next Cartesian sign convention, that is heights are measured. Heights are measured upwards. Heights measured upwards and perpendicular to the principal axis. Such heights are taken as positive. Heights measured upwards and perpendicular to the principal axis, such heights are taken as positive. Heights measured downwards and perpendicular to the principal axis, such heights are taken as negative. Heights measured upwards and perpendicular to the principal axis, such heights are taken as positive. Heights measured downwards and perpendicular to the principal axis, such heights are taken as negative. So these are 6 very important new Cartesian sign conventions. Okay, the first new Cartesian sign convention is all the ray diagrams drawn with the incident light must traveling from where to where? Left to right. All the ray diagrams drawn with what? What is this? Incident light. Must traveling from where to where? Left to right. So this is the first new Cartesian sign convention. The second one, all the distances are measured along the principal axis from the pole. All the distances are measured along the principal axis from the pole. So that is the second sign convention. If the distances are measured in the direction of incident light, if the distances are measured in the direction of incident light, that is from left to right, such distances are taken as positive. If the distances are measured opposite to the direction of incident light, such distances are taken as negative, right? So, and the heights measured upwards and perpendicular to principal axis, such heights are taken as positive. Heights measured downwards and perpendicular to the principal axis, such heights are taken as negative. So these are the 6 very important new Cartesian sign conventions. Okay. So according to new Cartesian sign convention, radius of curvature and focal length of convex mirror is positive, and according to new Cartesian sign convention, radius of curvature and focal length of concave mirror, so that is negative, right? Okay, the next topic is rules to find the image formation. Rules to find the image formation in case of spherical mirrors. What are the rules that can be used to find the image? Okay. What are the rules that can be used to find the image? That is in case of spherical mirrors. Okay, rule number 1. This is rule number 1. First, let us consider a concave mirror. What is this? Concave mirror. Light gets reflected from inside the surface of a part of hollow sphere. So this is the center of curvature. This one is the principal focus. This is the pole. Pole to focus is the focal length. Pole to center of curvature is radius of curvature. Radius of curvature is twice the focal length. Focal length is half of the radius of curvature. So whenever a ray of light is incident on the silver surface of concave mirror, whenever, this is rule number 1, whenever a ray of light is incident on the silver surface of concave mirror, so after reflection, the reflected ray passes through the principal focus. So this is rule number 1 in case of concave mirror. But in case of convex, let us consider the convex mirror. This is pole, this one is the focus, this is center of curvature. So ray of light is incident on the silver surface. Ray of light is incident on the silver surface of convex mirror, and this ray is parallel to the principal axis. So after reflection, the ray appear to diverge from the principal focus. So this is rule number 1 in case of concave and convex. Whenever the ray of light is incident on the silver surface of the concave mirror, the ray parallel to the principal axis. So after reflection, the reflected ray, that is, passes through the principal focus. That is in case of concave. But in case of convex, whenever the ray of light is incident on the silver surface of the convex mirror, the ray parallel to the principal axis, after reflection, the reflected ray appear to diverge from the principal focus. That is rule number 1. So the second one is consider the concave mirror. This is a pole. This one is center of curvature. This is principal focus. So ray of light passes through the principal focus, incident on the silver surface. After reflection, the reflected ray goes parallel to the principal axis. Whenever the ray of light passes through the principal focus, incident on the silver surface of the concave mirror, after reflection, the reflected ray goes parallel to the principal axis. That is rule number 2. That is in case of concave. But in case of convex, so this is focus, center of curvature. So whenever the ray of light is incident on the silver surface of the convex mirror, the ray appear to pass through. The ray appear to pass through the virtual focus. So after reflection, the reflected ray, goes parallel to the principal axis. After reflection, the reflected ray goes parallel to the principal axis. So this is rule number 2. So rule number 2. Okay, so next one, let's consider again here concave mirror. So this is the pole, this is focus, this one is the center of curvature. So whenever the ray of light passes through center of curvature and incident on the silver surface of the concave mirror. Actually, this is the normal incidence. The line joining from any point of the mirror to its center of curvature, that will be the normal. So after reflection, the reflected ray retrace the same path. After reflection, the reflected ray retrace the same path. This is in case of concave. So this is actually rule number 3. This is rule number 3, right? But in case of convex, this is convex mirror. This one is a pole. This is focus. This one is the center of curvature. So whenever the ray of light is incident on the silver surface of convex mirror, the ray appear to pass through the center of curvature. Okay, so whenever the ray of light is incident on the silver surface of the convex mirror, the ray appear to pass through the center of curvature. So after reflection, the ray retrace the same path, because this is normal incidence, so this is the point of incidence. So the line joining from point of incidence to the center of curvature, so this will be the normal. Okay, so here ray of light is incident normally. After reflection, it retraces the same path. That is rule number 3. Okay, so the next rule number 4. What is this? Concave mirror. This one is the pole. This is focus, the center of curvature. So ray of light is incident obliquely at pole. The ray turns back. The ray bounces back obliquely. Okay, actually the reflected ray obeys the second law of reflection. Actually here the angle of incidence, that is exactly equal to angle of reflection. So CP is normal at the point P, right? So this is incident ray, so this one is angle of incidence, this one is angle of reflection. So whenever the ray of light is incident obliquely at pole, the ray bounces back, turns back obliquely. So this is in case of concave, but in case of convex, this is the convex. So this one is the pole, this is focus, this is the center of curvature. So ray of light is incident obliquely at pole, the ray turns back, the ray bounces back obliquely. Okay, so this is the last rule. So these rules can be used to find the image formation in case of the spherical mirrors. The first rule, in case of concave, whenever the ray of light is incident on the silver surface of the concave mirror. After reflection, the reflected ray passes through the focus. So, in case of convex, whenever the ray of light is incident on the silver surface of the convex mirror, after reflection, the reflected ray appear to diverge from the principal focus. So, rule number 2. Whenever the ray of light passes through the principal focus incident on the silver surface, after reflection, the reflected ray goes parallel to the principal axis. So, whenever the ray of light incident on the silver surface of the convex mirror, it appeared to pass through the virtual focus. After reflection, the reflected ray goes parallel to the principal axis. So, this is rule number 2. So, the next one, whenever the ray of light passes through center of curvature incident on the silver surface. So, after reflection, the reflected ray retraces the same path. Okay. So, this is in case of concave. But in case of convex, whenever the ray of light is incident on the silver surface of convex mirror, the ray appeared to pass through center of curvature. Then after reflection, the ray retraces, reflected ray retraces the same path. So, last one, whenever the ray of light is incident obliquely at pole, okay, after reflection, the ray turns back obliquely. Okay, whenever the ray of light is incident obliquely at pole, the ray turns back, bounces back obliquely. It obeys the second law of reflection of light. So, these are the 4 very important rules, so that can be used to find the image formation in case of spherical mirrors. Okay, thank you.